यस तेजेंद्र, कोई डाउट है? एनी डाउट्स? ठीक है, अपना कैमरा बंद कर दो, बाकी लोग आएंगे। मैं पंपिंग एंड पाइपिंग अरेंजमेंट स्टार्ट कर रहा हूँ, ठीक है? So there are mainly three types of pumping and piping system on oil tankers: ring main and direct line free flow system, and we also have a combined system of direct and free flow system. So let's see. So this is the pumping and piping diagram. You have the bilges and strainers and scuppers. So you have around 5 tanks, 1, 2, 3, 4, 5. Then you have, sometimes you have engine room here, and then you have number 5 tank also. Then how we do the drainage, blasting, everything, we will see. Let's discuss the pumping and piping arrangements on. First, we will see the hazards of oil tankers. So let's see what are the hazards on oil tankers. So mainly the hazards compose of three things: either the oil or any chemical or gas. You can either inhale or ingest, or you can get skin contact. So if you inhale any harmful gas, then you will have breathing problems, and the solution is you have to move immediately to fresh air. Now, if you ingest any chemical or gas, so it goes in your stomach. So either first thing is you can put 2 fingers and you can try to do vomiting somehow, or you can take a lot of water to dilute, and then some milk. This kind of antidote absorbs most of the chemicals or acids. Then next thing is skin contact. If anyone on the deck gets skin contact, so we have to flush with fresh water. So on deck, many places you have showers. And then some different chemicals are different poisonous, and they have some antidotes. So for some chemicals, if they are ingested, we have to take the specific antidotes, or mostly it is activated charcoal. So it will be in your ship's poison chest, and how it is mentioned in your MSDS, or we can check what is the antidote and give that if the person has taken in that chemical. So while entering any tank, proper ventilation should be taken. Then resuscitation equipment should be with the well-trained, and main precautions should be taken while doing any enclosed space entry, tank entry, ballast tank entry, cargo tank entry. Proper gas checks. Now, as per new Scott requirement is that ELSA we have to carry inside when we are going inside, and you have to carry the portable gas meters also as he's carrying, and walkie-talkies, and ventilation should be continuous as long as anyone is there in the space. So with air inhalation, you can have asphyxia or some health problems. Then sometimes you can touch a very heated cargo, so you can get skin burns. Then there is a problem with explosion, which is due to static electricity or some other, like smoking, welding. All these should be avoided for inflammation. So this is a ship loading jet fuel, and ventilation fans were moved to the second tank, and the officer entered the tank. And later on it was covered that in the pump room and there they had large concentrations of cargo leakage. Ventilation, and for static electricity we have to load the cargo slowly, and we have to do bonding and earthing, so that we will see again. So let's start with the MARPOL Annex requirements. So MARPOL 7378 is a protocol. MARPOL came into 73 and enforced in 83, and in 78 there were new regulations which were added. So we have 6 annexes in MARPOL. Annex 1 is for oil, 2 is for NLS, noxious liquid substances, chemicals. Annex 3 is for harmful substances, that is IMDG cargo, dangerous cargo. Then, but these are in packaged form, like in containers and all. And then Annex 4 is for sewage, pollution by sewage, prevention of pollution by sewage. Then Annex 5 is to prevent garbage pollution from ships. And Annex 6 is about air pollution from ships. So let's start with oil tankers. So you have Roman numbers 1, 2, 3, 4, 5, 6. So these are the years which these annexes came into force. So nowadays it's not asked that much. Then Annex 7 can come for ballast water management. Now let's see what are the MARPOL requirements. So first, Annex 1 is divided in 2 parts. One is machinery spaces and then cargo spaces. And machinery spaces and both cargo spaces are divided into 2 parts. So we have some special areas for MARPOL Annex 1. So machinery spaces discharge are divided in 2 parts, outside special area and inside special area. And cargo spaces discharge criteria also divided in 2 parts, outside special area and inside special area. So the ships proceeding for outside and inside special area, every time the ship should be proceeding en route. En route means it should be going from point A to B for the voyage and not circling around. So it should be engine should be moving and it should be doing some speed. Then oily mixture is coming from the pass through the oil filtering equipment. So you have to pass the oily water discharge through OWS, both inside and outside. You cannot put directly into the sea. Then oil content should not be more than 15 ppm. So in outside special area, oil content should not be more than 50 ppm. And for inside special area, this OWS should have a stopping device. It should stop automatically when it's having more than 15 ppm content. and it should also have alarm for more than 15 ppm. Then oily mixture should not originate from cargo space, because cargo space will be covered in cargo spaces criteria. So it should be only from engine room or machinery spaces. Even pump room is coming in cargo spaces. Then oily mixture is not mixed with oil cargo residue. So same thing, oily mixture should not be mixed with cargo residue. You can put anything in oil cargo in the machining space and then say it is machining space. It's not like that. Then there is oil record book, we will see. So part 1 of the oil record book is for machinery spaces and part 2 is for cargo spaces. So all the loading, discharging and ballasting and tank cleaning and accidental discharge, internal transfer of cargo will be put in the oil record book part 2 for cargo space, and part 1 will have bunkering, lube oils, gas oil, diesel oil, then how much is consumption and internal transfer, ballasting, cleaning, and sludge tank, ROB and landing reports all will be in your ORB part 1, generally signed by chief engineer. Every entry is done by chief engineer. So tankers more than 150 GRT need to have this oil record book, and oil tankers and other tankers more than 400 GRT need to have this oil record book. So this is a very good summary. And oil and oily mixture from any ship's discharge shall be prohibited in the Antarctic area. So Antarctic is the special area where no discharge is allowed. Then let's see cargo spaces. Cargo spaces, again, two parts: outside special area and inside special area. So the tanker should not be more than 50 nautical miles from the nearest land. If you want, you have you're doing tank cleaning, you have oily water mixture from slop tank or something, you can discharge it in the sea, but the tanker, your ship, should be more than 50 nautical miles from the nearest land. It should be en route. Then instantaneous rate of discharge should not be more than 30 liters per nautical miles. So in 1 nautical miles, when the ship is moving, you cannot discharge more than 30 liters of this oily water mixture. Then how much should be the oil in this? So the total quantity of oil discharging in this should not exceed 1 by 30,000 of the total quantity on board. So the amount of oil in your oily water mixture should not be more than 1 by 30,000. So if you are loaded 30,000 cargo and discharge, then 1 ton maximum of cargo you can discharge into the sea total. Then tank vessel has in operation an ODMCS. So this is oil discharge monitoring and control system. So same like here you have machinery space oily water mixture is passed through OWS, and cargo space oily mixture is passed through ODME. Why it is different? Because here we have different requirements. So this meter will calculate your IRD and total amount with the speed and all, and that requirement is not here. That's why these are different equipments. So of course ODME should be approved, and you should have a slop tank in arrangement, and you have to always pass the cargo through ODME. It should be working fine and tested. Then inside special area, any discharge into the sea of oil or oily mixture from the cargo spaces of an oil tanker shall be prohibited. So inside special area is nothing is allowed. So these are the special areas for Annex 1. So you can remember by like this: G square, B square, Raman, RAMAN Raman, G square, B square. So G is for Gulf areas and Gulf of Aden, that is G square. B square for Baltic Sea and Black Sea. And Raman is then again Red Sea. A is your Antarctic area. Then M is Mediterranean. Then again N is your Northwest European waters. And A is your African waters. Then you have a IOPP certificate, International Oil Pollution Prevention Certificate, as per Annex 1. It is issued by the administration stating that your ship is complying with all the equipment and certification and requirements and regulations of Annex I. So all certificates are for 5 years. So all oil tankers more than 150 GRT should have IOPP certificates, and other tankers more than 400 GRT should have IOPP certificate. Then it should be supplemented with Form A and Form B. So for Form A is for the ships other than oil tanker, and Form B is for oil tankers. It is a record of all the construction and equipment, whatever equipments like your OTME, OWS, and IGA system, all will be mentioned in this what we call IOPP certificate. Then next is oil record book. So this part we have already seen. Then SOPEP equipments. So SOPEP requirement is that you should know the equipments, and then for regulation 17, all ships above 150 GRT and above should have SOPEP, and other vessels 400 GRT and above should have all those SOPEP equipments. So you should have SOPEP equipments like your booms and drums and all those things. And then you should have SOPEP manual, which will contain all the ship's particulars, plans, then national contact list, emergency contact list, company contact list, DPA and all. And the plan should be approved by the administration. So different type of ship, you will have different quantity of equipments, and the inventory of equipment should be taken monthly and kept in this SOPEP manual. Then you should have a oil spill drill always. All this is coming in SOPEP part. Then ODMCS also you should have a manual, and cow manual. This is all your MARPOL requirements. So you should have a. Then the keeping record of ODMCS for the last ballast voyage. You have to keep records of ODMCS. Some ships are keeping for 1 or 2 years also. So ODMCS should be approved by the administration. Oil ships or all oil tankers above 115 GRT above should be fitted with ODME. And the other requirements we have to recording device should be able to record the continuous discharge in liters per nautical mile, total quantity discharge, ppm of the oil, and rate of discharge, how many liters per nautical mile. Then the record shall be identified as to time and date and shall not be kept for at least 3 years. Then as per Annex 1, there is an assessment for checking the condition of this oil tankers. It is called CAS, Condition Assessment Scheme, and it is as per the Statement of Compliance, Regulation 20. So all the machinery conditions, pipeline conditions, all those things, photographic evidence, paperwork records have to be submitted to the flag state for review, and that is called CAS Survey and Report. Then you have subdivision and stability information, then STS operation, plan and record of STS operation, that is regulation 41. So CAS survey was carried out concurrent with the first intermediate survey or renewal survey. So every year you have this 2.5 years intermediate survey or 5 years renewal survey. That time we'll do CAS survey. There will be thickness measurement also. Then after 2005, after 15 years of age, we'll have a thorough close-up inspection and thickness surveys. So anyone has any doubts? किसी को कोई डाउट है?
नहीं सर. हाँ भाई आ गए नहीं।
रजनीश। अच्छा।
अरे तुम लोग को बार बार म्यूट कर देता हूँ, बार बार अनम्यूट कर देता हूँ, क्या हुआ? हाँ, और क्लास ठीक है बीच में। शाम कुछ डाउट नहीं है तुमको?
अगर ना अभी उस टाइम मेरा मोबाइल में जहाँ रखा हुआ था वो टेबल से नीचे गिर गया तो पूरा स्विच ऑफ हो गया था। अभी जस्ट अभी कनेक्ट किया सर। ऑन
वेरी
ही नहीं
गुड।
हो रहा था। पाइपलाइंस के बारे में सर बता दिया क्या?
नहीं, पाइपलाइन ही बताने जा रहा हूँ, वही निकाल रहा हूँ। So now we are going to see about the pipelines. Ready? Sham?
Yes sir.
3 types of pipelines: free flow system, direct line system, and ringmain system. It's given in your Harold Fernandez book. So first, let's see direct line system. Direct line system, you have only one line, and one line you have branch lines for each tank. So on oil tankers, you have what you call 3 tanks division: center tank, starboard tank, and port tank. So this line, center line is going and it is dividing into starboard tank and port tank and center tank walls, and you have the crossover walls and line is going here. Then you have same for each tank, 1 2 3 4 5, all lines are same. And you have here, this is the master wall. So this master wall is for tank number 1, this master wall tank number 2, master wall for 3 4 and 5 is directly in the pump room. So you have one pump and all the cargo directly will be taken from this line. So very simple pipeline system, only one line system. So advantages is less pipeline, less amount of cleaning, less maintenance required, but you can carry only one cargo. So advantages is less maintenance and easy discharge, fast discharge. But disadvantages is only one grade of cargo can be loaded. And if there is a leak in any valve, then it will be very difficult to uh, load or discharge the cargo because there's only one line. Then you have a free flow system. What is this free flow system means? You have 5 tanks, 1 2 3 4 5, and port, starboard and center. So we have this bulkhead tank bottom, we have a bulkhead gate valve. So we open this valve, so all the cargo will come from starboard to center, port to center. Same way on all the tanks, all cargo will come in center tanks. Then we will open this center tank valve, and from tank number 1 the cargo will flow to number 2. From tank number 2 it will flow to number 3 to 4 and 5. So all the cargo will be collected in the last tank, and then from these lines we will take the all the cargo from the pump and discharge. So advantages is that free flow, good drainage, good stripping, and fast discharge. Again, disadvantages, only one cargo we can load. So these are used on oil tankers, and the only one cargo we can load. Pipelines are there, and the problem comes with this gate walls over a period of time. If this gate walls get a problem, then it is at tank bottom until the time you empty the tank. It is very difficult, or sometimes on top of the deck, the valve operating, because operating wheel is on the deck and valve is in the bottom of the tank. So either it can get stuck, or wheel can get broken, or the gate valve can get rusted. So valves give these problems. Then we have ring main system. Ring main system is what you call for loading different grades of cargo. That's the biggest advantage. So ring main is like your ring road. So in ring road, you can come from any road and go to any road, and you have many roads. Same way, you have 3 pumps and 3 pipelines, 3 or 4 pumps and pipelines in ring main system. So one line is going for center tank, one is going for starboard tank, port tank. So the system is such that you can load from center tanks, from port pump, you can load from port tank to from starboard pump, discharge. So all those multiple combination is there. Flexibility, very versatile and flexible design. So you have line for starboard, you have line for port, but you can interchange anytime. So you can put 1 port and 2 port, you can put some other cargo, 3 starboard, 4 center, you can put some other cargo, and you can discharge like this, 3 starboard and 4 center, and from this pump, or otherwise from this pump also. So ring main system is very flexible. But again, like your ring road, there are so many roads, so it will be expensive. Then lot of maintenance. But advantage is always everywhere you see you have double wall segregation, so cargo will not be contaminated. And lot of bends or cargo, so because of that you will have lot of maintenance also. So let's see what is written. So tankers have a varied complex pipelines, free flow system, direct line system, and ring main system. So free flow system, as we saw, is on large crude carriers. The biggest crude carriers will have free flow system with these gate walls required to discharge quickly. Large gate walls are built into bulkheads of the tanks to allow the flow from side tanks to the center tanks. And when you have the stern trim, it causes the oil flow to aftermost tank, and the suction of the main cargo pumps are situated in the last tank. The last bulkhead sluice valve permits a good drainage, and any residue is discharged in the stripping. This is the advantage, good drainage. Then direct line system is used on for 2 or 3 grades to be carried, is suitable for VLCCs, and it facilitates quick loading and discharging. So very quick loading discharging. Arrangement is simple with lines leading directly to the tanks. So as we saw, one line is going in all the tanks, and straight length of pipeline, so better suction and less pressure loss. But because we have very few bends, and we need very less maintenance, less leaks, corrosion is less. But line washing is also very simple and takes less time. But because all the tanks are connected, so first we have to discharge all the tanks, and then we have to flush all the lines, then only we can do the tank washing. That is a disadvantage. And very few walls, and so leaks, if there are any leaks, we cannot load many grades also, and we cannot have double wall segregation, and we can have contamination. Then ring main system is ideal for product carriers because we carry different product, different grades of cargo, different cargos, where several different products are carried simultaneously in the different tanks. So from the figure, we can see that any pump can be connected to discharge any tank, making it very versatile. So main thing, any pump for any tank is ring main system, different types of cargos. Cargo has to be pumped in roundabout route, but required two wall segregation is always maintained. So two wall segregation is the main advantage of ring main system. So contamination will not be there. Then the line washing can be carried out thoroughly without flushing into the tanks, but it takes a longer time due to number of bends. So because there are a lot of pipelines and going in ring shapes, so we need a lot of flushing, and it takes a lot of time, lot of bends, lot of joints, walls, lot of maintenance. Pumping rate is also slow because it's moving, corrosion is more, and skilled persons are required, and also expensive. So the operational procedures for loading, discharging, you have mostly done. So before the tank arrives at berth, we need, you are asked sometimes about the cargo documents. So port papers, cargo documents required is ship particulars and cargo ship certificates, any defects or in hull and machinery or equipments, berthing arrangements, tugs, state of the cargo tanks, whether all tanks are good and clean, ready, inerted, washed, how much is the gas content, manifold, how much is the pipeline, which manifold, what is the size, location, number. Then any requirement for tank cleaning in the port or inerting slops, oily water. Then once your ship is berthed, then they will come and check, give you the properties of the cargo, flash point, vapor pressure, density, and any other special characteristics, loading, discharging, temperature, harmful gases, quantity of cargo, loading sequence, storage plan, number of hoses connected, maximum shore pumping rate, topping off rate, and the pressure available at the manifold. Establishment of an efficient communication system with signals for emergency stop and the standby time required for normal pump stopping. So ship shore safety checklist will be done, and it will be agreed how and when you will stop, maximum rate. Then chief officer will inform the terminal any limitations of the ship, venting limitations or rate limitation, pressure limitation. Then any part of the cargo already on board, how much is the ROV of previous cargo on board. Then how we will do the venting, open or close venting. Generally open, closed venting nowadays with vapor return line. Then all safety checklist is completed. Surveyor will inspect the tanks and other readiness of inerting and crude oil washing on the ship. Then the pipelines will be checked to set. Cargo will be started slowly. Pipelines will be checked for leakage. Manifold connection also will be checked. Then PV walls and all will be checked. Alarms. Static charge is not developing, so we'll start very slowly. Gangway and all will be checked. Leakages, pressure, lines, everything checked. Then we'll take the samples of cargo, first foot sample. Then we'll check the temperature, density from the sample. It will go for analysis. Then we'll start, once the sample is passed, we start increasing the rate slowly and go up to the maximum rate and keep monitoring the temperature and pressure. Then once we finish loading, close the manifold, wait for 30 minutes, take the final alleged temperature, density, calculate the cargo and secure the lines. Same for discharging. Before that, we have to keep the inert gas system ready because the tank will get empty. Then there are other systems on the tankers. Preliminary diagram we have done. Gas freeing by use of inert gas. Gas freeing is done by steamers, maybe. Then you have cargo pipelines, stripping pipelines, ballast pipelines, inert gas pipelines, crude oil washing lines, steam heating lines to keep the oils in viscous state. Then other safety measures, no smoking, no naked lights, static electricity. Then gas equipments we have done, explosive meter, gas meter, is all is there in your LOL book also. Tank scope. Then IG system, crude oil washing. Then oil numericals. Any doubts? Sham,
Yes, sir.
any doubts?
नहीं सर, इसमें तो नहीं है सर. हाँ. सर,
क्या हुआ?
नहीं.
Then there is one question asked in this. What is the primary and secondary venting system?
Okay, sir.
What is that? What is primary and secondary venting system?
So primary is the fixed ventilation.
Okay.
And secondary is the portable.
Ventilation portable.
No, sir.
How is the ventilation done?
Hmm.
So let's see
Primary, secondary.
primary and secondary venting system
How much?
and how much alarm settings we will do. So every cargo tank, when you are loading the oil, there will be some pressure, correct? Yes or no?
Yes, sir.
And for taking out, releasing the pressure, we have PV valve, correct?
Yes, sir. PV.
But if PV valve is not working, in IG common line, we have PV breaker, correct? But if PV valve is not working, that is
Yes.
the primary means, then we should have a secondary means, that is the SOLAS requirements. So first is we need venting, and we need reasons for venting is to release the pressure.
Okay, sir.
So we will see all these things, that what is primary, secondary means, and what are the alarm settings of each. So this is a tank you are
Yes.
loading, and then you will have a venting system. If you don't release the pressure, this tank will explode or rupture. So we have a venting system, that is PV valve or this thing. So there are two means, primary means and secondary means. So primary means you have two things. One is mass riser and PV valve, because these two are connected. Mass riser is connected in the common line, and PV valve is connected. The separate PV valve is there for each tank. So this is a tank, and on top of that you will have a pipe, or it will be connected, and there will be a weight that is called PV valve, that we will see. So PV
PV
valve,
valve is a
yes,
PV valve is ये first
first
IGB system.
first venting system, primary venting system. And after PV valve, at the end in the common line, we have a mass riser. So if pressure is not releasing from the PV valve, we can mass riser is a manual controlled lifting PV valve. We can lift the mass riser and we can release the pressure from the tank. If we see in the CCR or locally that tank pressure is going high. Then secondary means also can be a PV valve. If you have two valves in any tank, then second PV valve is your secondary means. Otherwise, your pressure sensors in the CCR, they are the secondary means of venting, because you will see the pressure, and as per that, you will open the mass riser or the PV valve. So primary means is mass riser, and secondary means, primary means is mass riser and PV valve, secondary means is PV valve and pressure sensors. So these are high velocity vent valves. We will see what is that. So let's see the alarm settings. And sometimes we are asking if PV breaker, some people say PV breaker is not a secondary means. PV breaker is not a secondary means of venting, because it's there in the common line. Secondary means should be independent for each tank. So what should be the alarm setting? cargo tank pressure, generally maximum pressure cargo tank is designed for 2000 mm of water gauge, and vacuum side is designed for -350. So that is your PV wall operating pressure. So
PV
if
wall का
your
सर 1400 millimeter water gauge.
PV wall or PV breaker you are telling?
I'm telling sir PV valve sir. PV valve sir 1400 millimeter water gauge is
That
pressure
will
or
depend
vacuum sir
on
minus.
tank ship to ship design. This ship we are taking example that operating pressure of the PV valve is 2000 mm of water gauge. So different tanks, different ship design requirement, tank how much is the thickness, how much it can hold, as per that the pressure rating will be there. It will be mentioned in your VECS VEX manual, vapor emission control system manual. Okay. So if your PV valve is operating at 2000 mm of water gauge positive side and vacuum is operating at -350, so if PV valve alarm we want to set, can we set at 2020? No, the alarm should have a little bit difference from the pressure setting, because we should know, we should get an alarm before or after as per the requirement. So as per OCIMF Oil Company International Marine Forum, it is recommended that maximum 10% above the PV wall you should have the alarm setting 10% above the PV wall. So PV wall pressure is 2000, so 10%, that is 2200 will be the pressure setting. Vacuum side is -350, so 10% more is -385. We will have the alarm sensor in the setting in the CCR alarms. But this is for non-inerted tanks. If the tank is not inerted, that is maybe in dry dock or sometimes. But most of the times we have inerted tanks. The tank has inert gas. So if the tank is inerted, let's see what will be the pressure setting. We want to maintain positive pressure in the tank. So in inerted tanks, O2 level is less than 8% and we don't want any air to go. So vacuum side will have 100 mm of water gauge. Pressure side, of course, 10% more, so 2200. Now, if we are using a vapor return line, we don't want the tank to go negative. So again, if it is inerted, 100 mm of water gauge, non-inerted, then 10% less, that is -315. Positive side, we don't want the PV wall to lift because we want the vapor to pass through the vapor return line. So we will keep 10% less than the pressure, that is 200, 2000 minus 200, it is 1800. Okay.
Yes sir.
Any doubts? Yes, no.
सर एक मुझे डायग्राम चाहिए जैसे रिलेटेड अगर मिल जाए तो सर.
पीवी वॉल का
नहीं सर, इसका एक एक क्वेश्चन है जैसे उसमें डेक लाइन, ड्रॉप लाइन, स्ट्रिपिंग लाइन, क्रॉसओवर वाल, वाई पास वाल, मास्टर वाल, ड्रॉप वाल एंड टैंक सक्शन वाल.
ये अभी जो एरोल फर्नांडिस का था ना, इसमें है तो ये सारे वॉल्स मार्क भी हैं. अभी जो दिखाया था एरोल फर्नांडिस का रिंग मेन पाइपलाइंस का, स्ट्रिपिंग का नहीं है, बाकी तो है उसमें. मास्टर वॉल और तुम्हारा क्रॉसओवर वॉल, सक्शन वॉल सब तो है.
तो ये सर ये ड्रॉप लाइन, ये डेक लाइन में ही सारे वाल दिखाने होंगे ना सर ये?
हाँ, डेक की लाइंस में ही तो होंगे, और कौन सी लाइंस में होंगे?
नहीं, ये रिंग मैन डायरेक्ट और फ्री फॉल सिस्टम में नहीं थी.
डेक लाइन बोल रहा है वो, डायरेक्ट लाइन नहीं बोल रहा है. डेक लाइन तो मतलब सारी लाइंस, सारे सिस्टम की लाइंस तो डेक पे ही होती है ना.
हाँ सर, वो ये टैंकर का पूरा डायग्राम बना के दिखाना होगा, केवल ओनली पाइपलाइन दिखाना पड़ेगा इसमें एग्जाम में.
पाइपलाइन ही दिखाना, पूरा टैंकर कहाँ बना सकते हैं? इतना टाइम थोड़ी ना होता है, लिखना भी तो होगा. ठीक है, मैं क्वेश्चन आंसर
Yes, sir.
दिखाता हूँ, इसके बाद तो पता चलेगा। अभी ब्रेक ले लेते हैं,
Yes, sir.
मैं मीटिंग एंड कर रहा हूँ, उसके बाद फिर से चालू करेंगे।